When you face a choice in life, do you also habitually toss a coin to make a choice? But do you know that only a few simple components? You can make a circuit that can help us make choices, a circuit that is both interesting and rigorous. The first one is the NE555 timer. It is the pulse generator of the system, which is responsible for generating a continuous clock signal. Note that the notch direction of the chip should be consistent, then solder the first 10,000 ohm resistor. It connects between the discharge terminal of the 555 and the subsequent capacitor. Together determine the initial oscillation frequency. Let the LED start to flash at high speed. This is a 2N3906N transistor. It is the key to achieve the deceleration effect. It slowly changes the charging voltage of the timing capacitor and gradually reduce the pulse frequency. It simulates the process of coin rotation stopping. The second resistor is 10,000 ohms. It is connected between the positive and ground of the transistor, providing a stable bias voltage for the transistor, ensuring a smooth and stable deceleration curve. This is the start switch of the system. Press it and the circuit starts to work. Now solder a 1 microfarad capacitor. It works with a 1000 ohm resistor. Determine the initial flashing speed. Because of the value of farad, allows the LED to alternate quickly in the human eye, like a rotating coin. 10 megohm resistor. It has a large resistance. It is connected between the transistor and the 555's timing terminal. It controls the time constant of the deceleration process. The larger the resistance, the longer the transition from fast to stop, the longer and more natural the transition is. It is connected in series with the 10 megohm resistor. Together set the slope of frequency drop when the resistance is 3.6 ohms. The deceleration effect is very comfortable to the eye. It won't stop suddenly. The second one is 1 volt capacitor. It is connected to the positive pole of the transistor. Is used to stabilize the control voltage during deceleration, preventing jitter during flashing. Now install the second core chip CD4017 decade counter. It receives the clock pulse from the 555 and sequentially lights up the output pins. We only use the first 2 output terminals to control the red and green LEDs respectively. The 3 output terminals are connected to the reset pin. To achieve the alternating cycle of 2 LEDs. This is an internal capacitor. It is connected to the clock input pin of CD4017, which is used to filter out high frequency noise, ensuring technical stability and prevent false triggering. The red LED represents the reverse side. It is connected to the first output of CD4017. When the counter output is high, the red LED lights up, connected to 120 ohm current limiting resistor. To control the LED current within a safe range, ensuring brightness and without burning out components. Similarly, the green LED will also have the same current limiting resistor. The green LED represents the front. Only one of the 2 LEDs will be on constantly. Randomly display the result of the coin toss. Finally, connect a 9-volt battery. The circuit supports 5 to 12 volts. 9 volts is a common choice. Connect the positive pole of the battery to the circuit, and the negative pole of the power supply is grounded. This time, the circuit is in standby mode. Press the switch. The 2 LEDs start to alternate at high speed and gradually slow down. Finally, it stops randomly on red or green. This is a complete electronic coin tossing process, using electronic circuits to simulate random decisions, which is both interesting and rigorous.